Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to see for 12th mathematics. As already we are doing the first lesson, application of matrix and determinant. Last class we have shown elementary transformation of a matrix. We have shown just small recap for those things. Today we are going to learn one more important thing. Before that one, we must know what we have learned in the last class. Elementary transformation of a matrix we have learned. In this one, 3 steps is very important. First is exchange of rows or column is allowed. Second one is multiplying any scalar with any row is allowed. And third one is any 2 rows or column we can add, or we can multiply any row with a scalar and then we can add also. The value of the determinant is not, matrix is not going to be changed. That we have shown. For understanding purpose, I will say in Tamil also. அதாவது ரெண்டு ரோ வந்து நம்ம மாற்றிக்கலாம், எக்ஸ்சேஞ்ச் பண்ணிக்கலாம். செகண்ட் வந்து ரெண்டு ரோ வந்து ஆட் பண்ணிக்கலாம், இல்லைனா ஸ்கேலார் இல்லை மல்டிப்ளை பண்ணி ஆட் பண்ணிக்கலாம். இந்த பாயிண்ட் 3. செகண்ட் பாயிண்ட் வந்து ஒரு ஸ்கேலார்னா நம்பரால் ஒரு ரோவை இல்லைனா காலமை நம்ம மல்டிப்ளை பண்ணிக்கலாம். அதுதான் இங்கே 3 இந்த ஃபாலோ பண்ணி நம்ம எலிமெண்ட்ரி டிரான்ஸ்ஃபர்மேஷன் மெத்தட் பார்த்தோம். ஸோ அது எப்படி நம்ம மேட்ரிக்ஸ், ஹவ் வி ஆர் கோயிங் டு சேஞ்ச் த மேட்ரிக்ஸ் இன்டு elementary transformation method we have shown. And then after that one definition we have shown, that is elementary transformation, that is 2 matrix are equivalent. ரெண்டு matrix equivalent எப்போ சொல்லுவோம்? When we are going to say 2 matrix are equivalent means if one matrix is obtained by elementary transformation method by some other matrix, then 2 matrix we called as an equivalent matrix. So same matrix only, but we have modified, apply some result, then they two are equivalent, not equal, equivalent. The value meaning will give same. And then after that one, row enhanced form we have shown. Row enhanced form means like a lower triangle, zeros have to be become. Likewise we have to convert the given matrix into row enhanced form. To convert, for conversion also we are going to use what? Elementary transformation. That 3 method only we are going to see. After that one problem we have done. And then rank of a matrix. Rank of a matrix is already we have done. That is, rank of a matrix A is defined as the order of highest order non-vanishing minor of a matrix. That is, if you find a determined value, the value should not goes to 0. If such matrix is there, then that will be a rank. For example, 3 by 3 matrix we are taking and its determined value is not goes to 0, that is the rank. Suppose that 3 by 3 matrix goes to 0, determined value goes 0, then we need to look 2 by 2 matrix, that is minor. Eliminating one row or one column, we can eliminate and find the minor. In that one it's going 0 or not, we need to check each and everything. If it is 2 by 2 minor is not equal to 0, then we will say it's an rank is 2, we can say. And then one more note we have some, the rank of the 0 matrix is defined to be 0, we are saying, because any element you take it will be a 0, that is the thing. And then rank of a matrix using row enhanced form we have some. Why we need to convert row enhanced form means to get the rank of a matrix. If you to get a rank means easily, if we convert it as a row enhanced form, how many non-zero rows are there, that is the rank of the matrix we have shown. You just have a recall of those things. And then finally we have quickly result we have shown. And then after that one, how to convert row enhanced form we have shown. Till then we have shown this shown in the last class. Now today we are going to learn about Gauss Jordan form. That's very important. What is a Gauss Jordan form? We have to look the same here also. We are going to operate what we are going to operate means elementary transformation method only we are going to operate. But using that one, how we are going to convert the matrix, that we are going to see. Using this one we have to solve. We can solve system of non-zero matrix. We can solve that one. That is, it may be a 3 variable problem or 2 variable problem. We can easily solve this one. So we'll do Gauss Jordan form. After that one we'll solve the any 3 variable equation we can solve. See that what's the Gauss Jordan form. Now we are going to see Gauss Jordan method. Gauss Jordan method is what we have to know, means the simple thing, that is AB equals to BA equals to I we are saying. That is already we have discussed in inverse. Okay. So in inverse what we have done now, A inverse equals to A inverse A equals to I. Okay. That's the thing we are saying in the inverse definition. Okay, but in place of B we have written A inverse. That is the same thing. So that's why in Gauss Jordan method, what actual meaning means, to find inverse only we are doing. Here instead of saying A inverse we are saying here B. Okay, here what we are going to do, that same logic only we are going to do to find the inverse. Here one problem is that with this method you can easily understand what we are trying to get. See, in this one problem is given, what the example 1.20 is saying means, find the inverse of the non-zero matrix. The word they have mentioned is here non-zero. Non-zero means determined A value should not goes to 0. You can take the matrix here 0, 5, minus 1, 6. Okay, just find the determinant 0 into 6, 0, minus 1 into 5, minus 5. So answer we are getting. Now you can see here 0 minus of 5. So minus into minus plus 5 is there, which is not equal to 0. Okay, which is not equal to 0. That's why they are saying non-singular. Non-singular matrix. Non-singular means determinant value is not equal to 0. It's coming. One more thing I want to say, that already in the formula we have written A inverse equals to 1 by determinant A into adj A. In the beginning we have done. Okay, adjoint of A. You can see this determinant A value is there. If this turns to 0, now the entire inverse will turns to not defined. For that reason only they are saying it should be what? Non-singular. That is it should not be non-zero. Non-zero na, it will be a non-singular matrix we can say. By value wise it should be non-zero. If it is value is non-zero, then that matrix you call it as a non-singular. That's why they are saying that find the inverse of a non-singular matrix. If it is not saying this Gauss Jordan method, no need to do this one. Straight away you can do this A inverse equal to 1 by determinant of A into adjoint A, where directly you can find it here. Okay, so since you have mentioned as a by Gauss Jordan method, means you have to do follow the steps what we are doing. In book is some other method is done. I am doing in some other here. So try to understand what we are trying to do here. The procedure is you have to write like matrix symbol here A and then here I2. Why it's I2 means it is of matrix what 2 by 2 matrix. So that's why it's I2. If it is 3 by 3 now, here it also will come 3 by 3. How we are going to write? Make a square bracket. This is 0, 5, minus 1, 6. One small line, then I means 1 0 0 1. That's the close of this matrix. Now your ultimate aim is try to make this as a I. This should become as a I. This will automatically become B. So that only the procedure we are going to get here. So now how to change that one? Already I told you, you should in 3 by 3 matrix method you follow in the last class itself. Here so simple. So your aim is this 0 should become 1 and this 6 should be become as a 1. That only the things you are going to do here. So for that one, first you follow this one as a 1. First you follow this as a 1. How you will make 1 now? Using elementary transformation method operation you can proceed here. What I am going to do here minus 1 is there. If I multiply with the minus, the value, or if I subtract it, this will become what? Plus 1. So I am going to write R1 because I want to change this one. That's why I am going to write R1. R1 will turns to R1 minus R2. R1 will turns to, how I am going to change R1 now? R1 minus R2. That is, here you can look at 0 minus of minus now plus 1. 0 plus 1, 1 will come. For that reason only I'm using this command. So what will become 0 minus 0? 0 minus of minus, this will become 1. 5 minus 6 is, answer is minus 1, and this will left as a minus 1 6 as such. Okay, so similar way you have to operate this also. What you have done? R1 minus R2. Now 1 minus 0 is 1 here, 0 minus 1 is minus 1 here, here 0, this is 1. That's the thing. First step I have done. In this first step, this will become what? Here 1. Next, what you need to do? This you make it as a 0. This you make it as a 0. How you are going to make a 0 now? Simple. You just add this 2. Automatically you will get it. So what I am going to write? R2 will goes to R1 plus R2. R2 will goes to R1 plus. Why now? If you add this 1 minus 1, answer is 0. For that reason only we are going to do this one. So that it will become as, I am not changing R1. So that's why you write 1 minus 1 as such. This alone you add it, 1 minus 1, 0. Minus 1 plus 6, 5 will become. And then here what will become here? Here what will become? R1 plus R2 you need to write. So this you write as such. Add 1 plus 0, 1 will come. Minus 1 plus 1, 0 will come. So that's the second step we have done. In this one, this will become 1, this will become 0. This we need to make as a 1. This you want to make a 1 now. What you are going to do? R2 will goes to R2 by 5. I am dividing by 5. If I divided by 5, what it's coming? You just check it now. So this will become 1 minus 1. 0 by 5 is 0. 5 by 5 is 1 here. Okay. So next one, 1 minus 1. This is 1 by 5. This 0 by 5 is 0 only will come. So that's the thing we are having. And now you can see here 1, 0, 1. Now left is this you need to make a 0. This you want to make a 0. Now simple, you just add it, you will get as a 0. So now you can write R1 goes to R1 plus R2. You just add this 2, automatically answer will become 0. So what is this one? 1 plus 0. R1 only you need to change here. So change that one. 1 plus 0, 1 will come. Minus 1 plus 1, 0 will come. So R2 is remaining same. So now 1 plus 1 by 5. Because you need to add 1 plus 1 by 5. In adjacent I am doing. 5 ones are 5. 5 plus 1, 6. So 6 by 5 will come. So this answer is 6 by 5. So then next one, minus 1 plus 0 is minus 1 only. This is 1 by 5 and this is 0. So that's the answer we are getting. Is that clear? So you can easily see here, that is the inverse. This is this here in the beginning, this is A, this is I2. In the last, this will become I2, this is our B. So that B is nothing but A inverse we can see. Now you can see here, my Gauss Jordan method is this one only. So A I2 is there. A, this is I2, that is a identical matrix. I2 means. So we, after operating few operation, we convert this A as a I2. Then this will become B, we can say, according to that formula. R, that B is nothing but inverse. So finally there is no space. So I am just writing here for understanding. So therefore A inverse is nothing but what you will do. What you have converted here, you can write here 6 by 5 minus 1. 6 by 5 minus 1, and then this here 1 by 5, 0 is there. That is the thing we are going to write here. One more thing you can note, you can take this 5 out. Okay, in book back answer will be 5 commonly divided by 5 you are taking commonly means 1 by 5 you are taking common limits. Here 5 is that by 5 is that you are taken, so 6 will come. Here 5 is that it's taken, now 1 will come. Here 0, no need to problem. Only this is there, so that's why multiply by minus 5. Then multiply this scalar 1 by 5 into minus 5, minus 1 will come. So in this format will be your book back answer. One more thing you can understand, this rule which I have written, this 3 rule is differ from your textbook. Okay, this rule is our wish. Okay, just I am saying in Tamil, இந்த ரூல் வந்து புக்கில் இருக்கிற மாதிரி இருக்காது, நான் மாற்றி எழுதியிருக்கேன். ஏன்னா புக்கில் இருக்கிற மாதிரியே எதுவும் அவசியம் இல்லை. இது கொஞ்சம் பெட்டராக இருக்கும். அங்கே டிவைட் பண்ணுவாங்க, இங்கே டிவைட் பண்ண மாட்டாங்க. ஒன் மோர் திங், புக்கில் இருக்கிற ஆன்சர் இந்த மாதிரி வரும். நீ வந்து இது வரைக்கும் ஸ்டாப் பண்ணலாம். we can leave by this stage, no problem. Okay, so now we will go one more problem, that is 3 by 3 matrix, that is example 1.21. Okay, have a look this one. Find the inverse of A. Find the inverse of A. What's the A matrix? You can see 2 1 1 3 2 1 2 1 2. By, if it is not given, you simply directly what you can do, by applying the formula you can easily find it. Inverse, that is A inverse equal to 1 by determinant of A into adjoint A. But here the word they have mentioned Gauss Jordan method, so we need to follow that one. See, carefully do. 2 by 2 na easy, here 3 by 3 is there, carefully do. This is A matrix bar I3. Why I am writing here I3? In that case I2 means 2 by 2 matrix. Here it is a 3 by 3 matrix, that's why we have written it's a I3. How we are going to find solution? Let me check us. Now A, what's the A matrix is that? That is right away you write, that is 2 1 1 3 2 1 2 1 2 is that. That is a matrix what? A. I3 na 1 0 0 0 1 0 0 0 1 is that. That's a matrix. Carefully do the steps, you can easily get it. I told you, you make a ya shape and then see, this should be 1 in this position, this should be 1 and then this should be 0 and then this should be 0. Make use of this one to make this 2 as a 0. After this one, this you make as a 1 and make this as a 0, or you can make this as a 0. This 2 you apply to get the 0. Okay, after making this one, then this you make it as a 1. Diagonal entries should be 1. Diagonal entries should be 1. After making this as a 1, these 2 entries make a 0 with the help of this one. Then it will be, task will be easy. Okay, see, ya shape, keep it in mind. Like this it should become. So it will be easy. Now come to the problem. I want to make this should be 2. So see, this alone, row operation alone you do it, don't do column. Okay, this I want to make it 2 as a 1. Now what I should do now? You check that what we can, which row which we can separate. If I separate this 2, answer is 0. 2 minus 2 0. So that's why I am doing 3 minus 2, answer is what will come? 1. So I am going to change R1 because I want to make this one only no 1. So that's why I am changing the row. First row I am going to change. How I am going to change means 3 minus 2 is 1. So that's why R2 minus R1. I am going to, how I will change now? R2 minus R1. That is, you can easily see here I am writing 3 minus 2, answer is 1. 2 minus 1, answer is 1. 1 minus 1, 0. That's it, simple. So this is 3 as such, this is 2 as such, this is 1. This is 2 1 because we are changing only what? R1, row 1 only I am changing. Similar way you need to do for identical matrix 2. R1 goes to R2 minus R1, that is 0 minus 1 minus 1, 1 minus 0 0, 0 minus 0 0. This is 0 1 0, this is 0 0 1. That's the first step we have done. So I make as a 1. Now we can see small mistake I have done. You can see 0 minus 1 is minus 1. 1 minus 0 is 1 minus 0 1. So that means here it should be 1. Okay, 1 minus 0 is 1 here. Then 0 minus 0 0. Remaining you are writing. So first my task is this, you need to make a 1. I have done. Now with this one I need to make these 2 entries should be 0. Now I am going to do that one. You can see here, this is 3. If I multiply by this row 3, 3 ones are 3. 3 minus 3, answer is 0. So I am going to make this entry 0. This 2 entry 0, no. So same with the help of this one. Same thing with this help of this one, I want to make this 2 entries 0. So what I am going to do, R2 will goes 3 times R1, because if I multiply 3 here, 3 ones are 3. 3 minus 3 is 0, no. That's why 3 times R1 minus R2. That is the command I am writing here. Okay, so I am changing R2, so that alone you change. R1 you write as such 1 1 0. 3 ones are 3. 3 minus 3, 0. 3 ones are 3. 3 minus 2, 1. 3 zeros are 0. 0 minus 1, minus 1. That I have done. Is it clear? I am multiplying R1, this row 1 as a 3 and subtracting with R2. 3 ones are 3. 3 minus 3, 0. 3 ones are 3. 3 minus 2, 1. 3 into 0, 0. 0 minus 1, minus 1 I have written. Next one. Here, simultaneously I am multiplying. Minus 1, 1, 0 is there. So multiply R3. Minus 3 into 1, minus 3. Minus 3, 0 now, minus 3 only. 3 ones are 3. 3 minus 1, 2 will come. 3 zeros are 0. 0 minus 0, 0. That I have written. Alright. One more time. Second operation also I am doing here. Because R3 I am not using at all in this one. R2, R1, R2. So R3 I can use here. Now row through. This element I want to make a 0. That I have told you now. This I need to do. 2 is that. Similar logic we can write. R3 will goes to what number I should multiply, so it will become 2. 2 ones are 2. What number is the same number you multiply. 2 ones are 2. 2 minus 2 answer is 0 1. You know that's why I am multiplying 2 times R1. That I am multiplying 2 times R1 minus R3 I can write. This is a command. 2 command I am using in one step. So 2 ones are 2. 2 minus 2 0. 2 ones are 2. 2 minus 1 1. 2 zeros are 0, 0 only. 0 minus 2, minus 2 will come. Is that clear? Similarly, here I need to operate. That is 2 into minus 1, minus 2. Minus 2, 0, minus 2 only. 2 ones are 2. 2 minus 0, 2 only. 2 into 0, 0 only. 0 minus 1 is minus 1. Now you can see this is 1, this 2 into 0 as like here. Okay, this is 1, this 2 into 0. Next what I need to do, this middle one should be 1. Here already it is 1. No need to do that operate. So easy work. Next, making this one, I need to make 2 into 0. This below 1 0 and above 1 0 I need to make. So here I am going to do that one. You can see I am not going to change anything. This already 1. This I want to make a 0. So what the command I am going to write now? R3 goes to, since this also 1, this also 1. So simple. I am going to do R2 minus R3. So 1 minus 1 0. No, for that reason I am writing here. So 1 minus 1 0. That 0 I need to write in R3. So what will be the command? You can see I am going to operate two condition. I want to make this also 0. That command first will do. Then you will do this one. Anything you can do. I am not going to change R2 here. So I am going to change R1 and R3. So that's why 0, 1, minus 1. Better we will do minus 3 to 0. I am not changing. I am going to change R3. And then I need to make this as a 0. What's that one? R1 goes to R1 minus R2. That is 1 minus 1, 0. I want to make, you can see here, this is 1. This entry 0, this entry I need to make a 0. Here you can see already it's 1. This 2 entry I need to 0. To make this 2 entry, I want to make these two commands. R1 will goes to R1 minus R2. Row 1 will change. R3 will goes to R2 minus R2. That is, this row will change. That one I am going to do. First I will do this one. R1 will goes to R1 minus R2. That is 1 minus 0, 1 only will come. 1 minus 1, 0 will come. 0 minus 1 plus 1 will come. So this is over. Similarly here, minus 1, minus of minus not plus. So plus 3 minus 1 is 2 will come. 1 minus 2 now, minus 1 will come. 0 minus 0 now, 0 will come. That's the thing we have done here. Here R3 what I need to do? R2 minus R3. R2 minus now 0 minus 0, 0. 1 minus 1, 0. Minus 1 minus 2 now, minus of minus plus. So plus 2 minus 1 is 1 will come. Is that clear? So minus 3 minus of minus now plus 2. So minus 3 plus 2 is minus 1 will come. 2 minus 2 answer is 0. 0 minus 1 plus 1 will come. You can easily see. You can see here 0 minus of 0 minus of minus 1. That's why 0 minus into minus plus 1. So don't forget this formula minus. Okay, so that's the thing. Now you can see here this in this step what I have done now, these two entries are 0. In previous one this two entries I make a 0. In that first one this I make it as a 1. So this is the thing we have done. Next final step, you need to make this as a 1 because in this formula I have written what 1. So already it's existing, no need to do anything. Okay, so this is 1. With the help of this one, these two entries I need to make a 0. So simple. Here also what I am going to do here means, see R1 again I am changing. R1 will goes to R1 minus R3. R1 will goes to R1 minus R3. Now 1 minus 1 0. This will become, for that reason only I am doing. So that if I am doing now 1 minus 0 1, 0 minus 0 0, 1 minus 1 0. That's the row 1. Here you need to do R1 minus R3. 2 minus of minus na plus 1. So 2 plus 1 3 will come. Minus 1 minus 0 na minus 1 only. 0 minus 1 na minus 1 will come. That's the thing we have written. Okay. So in this problem we are not doing R2 any changes. So you write as such 0 1 minus 1 will come. Here minus 3 2 0 as such, because we are not going to change 0. So next what we are going to do here means, oh sorry ma, I have done 0 0 1. Okay, so this entry I have made. This I need to change as 0, no, but I have written here, no need to write as such. We need to write one command. What's the command means? See here, I have made this entry 0. Now I need to make this entry 0. To make this entry so simple, what I am going to now, R2 will goes to R2 plus R3. R2 will goes to R2 plus R3. See here, R2 goes to R2 plus R3. That is 1 minus 1, answer will become 0. That I need to write on R2. Okay, we are not doing anything with the row 3. I have wrongly written row 2. That's why I have strike here. You just operate it. 1 plus I have to add. Okay, I have to add it. So that is the thing I am doing. R2 plus R3. Stop. So now we are going to do R2, that is this row 2 goes to R2 plus R3. You just add and write 0 plus 0. Then this also correct only I have written. Okay. 0 plus 0, 0. I have to write 1 plus 0, 1 will come. Then minus 1 plus 1 is 0 will come. Okay. Here minus 3 R2 plus R3. Minus 3 minus 1 minus 4 will come. 2 plus 0 2 will come. 0 plus 1 1 will come. Okay. So remaining R3 I am going to write as 0 0 1, and then here it's minus 1 0 1 will come. That's all. You can see here I am writing this step alone here down one more time. What's that one? 1 0 0 0 1 0 0 0 1 is there. Here you can see 3 minus 1 minus 1 minus 4 2 1 minus 1 0 1 I have written. So here strike work is there, that's why I am striking here. So 1 0, you can see here A, this is I3. Here it's come as a I3. Then this is what? A inverse. This is a inverse. Okay, are you getting? So simple. Make sure that you follow your style. You follow your style. It will be easy. First you this make a head 1. With the help of this one, these two entries make a 0. These two entries make a 0 0. After this one, this you make as a 1. After making this one, this make a 0 and this make a 0. Okay, this two entries should be 0. After this one, diagonal should be 1. Making use of this one, this entry and this entry make a 0 0. Then automatically it will convert as a identical matrix. Now you can easily say the inverse of the matrix is, I am writing here, inverse of A is A inverse equals to 3 minus 1 minus 1 minus 4 2 1 and minus 1 0 1. Okay, you can see here here I have used 1, 2, 3, 4 steps only, but you can see I am doing 2 operation in one. So totally 7 operation. 7 operation you have got the A inverse of this one. So that's very simple. One more thing, you may ask the question that why we have to put a headache here. Straight away we can do A inverse equal to 1 by determinant A into adjoint A. That formula will be easy, right? Why we need to do this kinds of things we have to do. Now we have to this much operation I have to do to get A inverse. Straight away we can follow this formula. A inverse equal to 1 by determinant of A into adjoint A. We can easily find this formula. You can say, since it's a 3 by 3 matrix means it's okay. Easily you can use this one. If it is coming 4 by 4 matrix or 5 by 5 matrix or 6 by 6 matrix, now you will get a confusion. In generally you can see in BSc, MSc we will do n cross n matrix. So general format we need to design. For that reason only it will be very useful to do this Gauss Jordan method. Okay. So now this is the important things. Using elementary transformation method we are doing so many things. Row Ehlers form we can doing. After that one how to get a rank we have shown, and then after that one using Gauss Jordan method how we are going to find inverse. One more thing, this is very important. If you follow 4 or 5 times this same problem, you practice it, you will get an idea how we have to do. Okay, one more thing, you can see a small calculation we have to perform here itself. Sometime I itself get confused which row is operating. So if you're practicing as much as we are taking, so we need to see all those things. Okay, so if you practice so many times this same problem, you can easily get an idea, oh, in this procedure only we have to follow. Like that you will get an idea. So that's why I'm going to give a homework already I have given. So you just follow that one. Please complete and submit. I have shown that no one is showing interest toward to submission of homework. So please listen this class and then try to solve all those homework sum which I have given. Okay. Lastly, we'll go to important one more concept, that is linear equation. Now we have solving of linear equation. Solving of linear equation. We will say system of linear equation. It may 3 variable, or we can say, or also we can do for 2 or also. What is a 2 variable? That also we can see. Okay, so solving of system of linear equation using matrix method. Okay, using matrix method we are going to do. Okay, so that's the thing we are going to see here. Okay, it's very important. Solving means you know that one, finding a solution. Using matrix na matrix only. What is the system of linear equation? What is a linear? What is the equation? You know, system means what? 2 variable, 3 variable. You must know. For example, equation means what? For example, x plus y equals to 10. This is nothing but one equation. So here x and y is a variable. Here how many variable is that? X1 variable, y1. So 2 variable, that's a 2 variable. Okay, it's how many equation? 1 equation. So okay, I will discuss that one. Now it's 2 variable, 1 equation. Why the word linear? Linear means you can see x highest power is 1, y highest power is 1. So it's 1. So for 1 only we are saying it's a linear. Is that clear? So linear means the variable power. Linear means variable power should be 1. Then we will say it's a linear. Linear means variable power should be 1. Okay, vice versa, variable power is 1 or linear. If it is variable power 2, like x square plus x plus 2, this you have studied in 10th standard. You can see its highest power of variable x is what? 2. So that's why we will say it's a quadratic equation we can say. I will say it's a quadratic. Why it's a quadratic na? Its highest power is 2. Why it's a linear na? Its highest power in this variable is 1. Okay. Why they are using system? That's very important. For example, x plus 10 equal to 0. It's a linear. Why? Its highest power is 1. So no problem. Next one, how many solution will get? For example, for x minus 10, if I am substituting, means what the solution will become? Minus 10 plus 10. Answer is what? 0. That only the 0. So x equal to minus 10 is a solution. X equal to minus 10 is a solution. Why we are saying solution? No, it has to be satisfied the equation. So how many variable is there? Only one variable. How many equation is there? One equation. So this is unique. Okay, so we'll get easy answer for this one. Okay, one variable, one equation. So how many solution? One solution. You can easily see one equation, one variable, solution also minus 10 only one number. Is there any other number you will substitute, answer will become 0? Never. You can't find any number. If you substitute in place of x, the answer will become 0. You substitute anything, unless until you are not substituting minus 10, you won't get 0. So that's why it's saying the solution. Okay, come back to this one. This is a linear equation I am saying. Now how many variable is there? 2 variable. How many equation is there? 1. Now you just see, if I can substitute x as a 0, x value as a 0, y value as a 10. Can I substitute? Add it 0 plus 10, answer is what? 10. So that is one solution. If I am substituting this as a 1, this as a 9, 1 plus 9, answer is what will come? 10. That is also a solution. If I am substituting this 2, this is 8, that also solution. Or I can say minus 1, 11, minus 1 plus 11, that also is 10. Or I can say this is 0.5, this is 9.5. So then also if you add now, it will come what? So solution. These are all solution only. You can give infinite number of, plenty of number you can give to satisfy the equation. But here it is not like that. Only one number, you can't do anything. Y means one variable, one equation, so definitely one solution. Here 2 variable, but one equation. So it is there now. The solution will be what? Solution will be infinite many solution. Infinite many solution. Okay, that we are having infinite many solution. One more thing you can see here. See, I'm just using one. Okay, if I'm having like this structure x, I will use this homework problem itself. 5x, we are having 5x plus 2y equals to 3. This one problem. Another is 3x plus 2y equals to 5 is done. That is another problem. I can use the same itself. For better understanding this, I am using here itself I have given x plus y equals to 10 I have written. You can see here we are getting infinite many solution. See, now x minus y equals to, I am saying some 5 I am saying. Okay, here how many variable? 2 variable. Okay, 2 variable. How many equation? 2 equation. Let me see solution how we are getting. So I am just solving this one. You just add it. If I add now, what I will get? 2x. Here plus y minus y, answer is 0. So 10 plus y is 15. So x value is 15 by 2. This is one value. Okay. So 15 by 2 is nothing but 7.5. So another equation is we are getting as x plus y equals to 10. X values I am saying 7.5 plus y equals to 10. Then y value we are getting 10 minus 7.5. Answer y value is what we are getting? 2.5. So that's the two things. You just substitute x value is 7.5. Y value is 2.5. Add it ma. If you add, answer is what? It's coming 10. Substitute in this equation. X is 7.5 minus y is 2.5. Subtract it. Answer is what we are getting? 5. Here we are getting 10. So that is it having unique solution. We are getting unique. Only one solution is nothing but unique. 2 variable, 2 equation. We are getting unique solution. That is x value is 7.5. Y value we are getting 2.5. That's the thing. So now come back to this one. One more time. I want to recall. 1 variable, 1 equations. Answer is 1 is coming. Here 2 variable, 2 equation. Solution is unique, it's coming. But if it is coming a linear, 1 variable, but 2 variable, 1 equation, we are getting infinite many solution. So you can indirectly you can ask me, sir, if it is 1 variable, 1 equation, one solution will come, 2 variable, 2 equation, or 1 solution will come. No, it's not like that. We are having 3 ways. See, this you can easily draw by graphical way also. For example, this I am drawing, you can easily understand. So x plus y equals to 10 is there. Is that correct? This you take a box in 10th standard you have done, no, x, y. I am doing intercept form, x by, I am throughout dividing by 10. So what you are getting, x by 10 plus y by 10 equals to 1. So x intercept is 10, y intercept is 10. If you draw x, for example, this is x10, this is y10. Now you draw the graph, it will be like this. So this is x plus y equals to 10. Okay, or else you put a box and give some numbers, you draw it, you will get this one. Another equation is what we are having, x minus y equals to 5 is there. So I am dividing by 5. What I will get, x by 5 minus y by 5 equals to 1 will come. That is x by 5. Minus should not be there. So plus I am writing y. That minus I am writing denominator. Minus 5 equal to 1. You can see here x 5. So here will come. Y is minus 5 now. It will come in down. So if you draw the line, it will goes like this. So this is nothing but x minus y equals to 5. Where these two line will intersect means this intersection of this point will be this one. What's that one? X is 7.5. Y is 2.5. You can draw in the graph. X value will be 7.5. Y value will be 2.5. This is 7.5, that is 2.5. That is a graphical solution. Okay, if you can do by elimination method, substitution method, which you have learned in 10th standard, graphical method also so on. So many methods are there. 5 or 6 method is there in 10th standard you have learned. So in this way you are getting solution. Okay. So here 3 solution is there. See, if the line intersect, unique solution. Unique solution. If line is not intersecting, it's a parallel. Parallel means no solution. No solution will come. If the line coincide, it's line coincide. Coincide means goes on one over another, na infinite many solution. Okay, that's the 3 things for 2 dimension. That is, you are using x and y. For that reason only it's 2 dimension. So it has 3 cases. If you are doing 3 by 3 matrix, you will get a 3 dimension, 3D image will come. There we have some more cases that we'll see. Okay, using this matrix method, now come back to problem. How we are going to solve this one using matrix, that we need to learn here. What the example you can see? Example, solve the following system of linear equation using matrix method. Using matrix method, matrix inversion method also we are saying. Inversion method you can say. What's the equation now? This is the equation. 5x plus 2y equal to 3, 3x plus 2y equal to 5. Now we will solve this one using matrix inversion method solution. What's the matrix inversion method now? We need to write a matrix Ax equals to B. This is a most general format. Ax equal to B. This you are going to get as solution x. X is nothing but here, if you multiply A inverse B, that is a solution. For this system, this is a solution. Okay, this is the matrix inversion method we can say. What is this Ax? A is a given matrix. Okay, matrix. B is a unknown thing. Okay, this B is, we are getting that right side we are getting. Okay, here x now you will get this together, solution will come. See here I am writing the equation, how we are converting, you can see 5x plus 2y equals to 3, this is one. Another 3x plus 2y equals to 5 is another one. Okay, so this I am going to write in the form, this is a procedure. I am writing as Ax equals to B, I am going to write. That is, A is what I am writing now. Just take the coefficient. One more thing, x should be there, variable, y variable should be there. Don't change that one. So here 5, this is 2, this is 3, this is 2. This is x coefficients, this is y coefficients. Here in adjacent, x and y you write, x and y, that two variable. Now that right side 3 and 5 is there, that right you write as a 3, 5. Okay, so this matrix is nothing but A, this is our x, this is our B. Is that clear? Is it clear? So you just multiply matrix multiplication, 5 into x, 5x, 2 into y, 2y, 5x plus 2y equal to what we are getting? 3. Same system of equation we have converted in a matrix method. Now solution you want to get means, I am writing here, solution you want to get means, what you need to get? Solution, x, solution procedure is what? A inverse into B you need to get. Okay, so now I need to get A inverse. Here matrix method is that, so straight away you can get this matrix is A is what we are getting, 5, 2, 3, 2. You can easily find what we can do now. That formula is there now. What's the formula? A inverse equals to 1 by determinant A into adjoint of A. That formula you can apply here. So what the thing I need? I need determinant A. So determinant A. Determinant A is what? Cross multiply. 5 2s are 10 minus 3 2s are 6. So answer is what we are getting? 4. 10 minus 6 is 4. So therefore A inverse we are getting 1 by 4. Next what you need to get? Adjoint of A you need to get. That's the thing we need to get. So how we are going to get adjoint of A? We will see. Adjoint means you can, I already told you, for 2 by 2 matrix is very simple. 2 by 2 matrix is very simple. What you need to do? I said exchange this to change the sign. Exchange this to change the sign. So straight away you can get 2, 5. This is minus 2, minus 3 will come. That straight away we have done in this one. Okay, or else you find minor matrix for A. Minor of A you find. Simple. What's the minor of A? This row, this, for this minor, this row, this column delete, not 2 will come. For this minor, this row, this column delete, not 3 will come. For this one, this row, this column delete, not 2 will come. For this one, this row, this column delete, not 5 will come. That is the 5. I have written answer already, but I am just doing minor. Next, cofactor matrix. Cofactor matrix means what I said, position sign. Position, this is positive, let it be as it. This position is negative, minus 3. This is minus, that is minus 2. This position is positive, 5. Y also I said, this first element, first row, first element. 1 plus 1, 2 positive. Even na positive, odd na negative. Here 1 and second row, 1, 1, 2. 1 plus 2 is 3, odd, that's why it's negative. Here 2, 1. 2 plus 1 is odd, negative, that's why negative. Here 5 na, 2 plus 2, 4. So that's why. So this is a cofactor matrix. After that one, what you need to do? RGA. RGA means you just take a transpose. Transpose now what will come? 2 minus 3 minus 2, 5. That I have already have written in a slide 5. In the beginning of the class itself, I told you to do. I have done this one. So just have a look at those video too. Okay. So here 1 by 4. Adjoint I got it. So I am writing in place of A inverse adjoint. That is what that one? 2 minus 2 minus 3 and this is 5 we are getting. That is the A inverse. Is that clear? Now I know the value of determinant A is what? I am getting 4. Adjoint I got it. I just substitute it here. What's that one? A inverse here. A inverse is 1 by 4. That is 2 minus 2 minus 3. 5 you will get. Multiply B. B matrix is what here? 3 and this is 5. Okay, now you need to multiply. What's the order? This is 2 by 2. What's this order? 2 by 1. 2 rows, 1 column. So multiplication is allowed. You can multiply. So 1 by 4 will come as such. Multiply now. 2 3s are 6. 2 3s are 6. Minus 2 into 5 minus 10. Is that correct? Okay, first row, first column over. Next, second row, first column. Minus 3 into 9 minus 9. Right? 5 5s are 25. What 25 plus 25? Alright. Now you can see this I am writing here. This is x value. X value is what getting 1 by 4. Here I have written as 6 minus 10 here I have written minus 9 plus 25 I am getting. So it just 1 by 4. Subtract it. 6 minus 10 is minus 4. 25 minus 9 is 16 we are getting. Now you can easily divide it. Minus 4 by 4. 16 by 4 you can divide it. So this is the value of x here. So here minus 1 will come. 4 4s are 16. So that's a 4. X is nothing but what here? X matrix is nothing but what? X, capital A, small x, small y. That is the value of capital. So here it will come x, y. So what the solution here? Therefore, x value is minus 1 and y value is 4. That is the solution. Easily by matrix method we can do it. You want to check your answer. Now what's the equation you check? What's the equation? 5x plus 2y. 5x plus 2y equal to 3 is that one equation. Another equation is 3x plus 2y equals to 5 is that is the thing. You just substitute. In place of x minus 1. In place of y as a 4. So what you are getting is just in place of x minus 1. In place of y 4. 5 into minus 5 minus 5. 2 4s are 8. 8 minus 5 is 3. It's getting answer. It's correct. 3 into minus 1 plus 2 into 4. 3 into minus 1 minus 3. 2 4s are 8. Add it. What you are getting? 5. We are getting answer. So what we have done is correct. So it is a solution of this one. Okay students. Now you have learned how to solve using matrix. How will you get the solution for this system of linear equation? You have learned it. Okay, I think it's very will be useful to you. It's very important sum too. Okay, here value based question also will come. How to convert, how it's practically helpful to us in our day-to-day life also we can see in this using this matrix inversion method. Okay, just since it's a 2 by 2 matrix I have done this. Next class inshallah we'll see 3 by 3. Why I am giving not taking 3 by 3 now? I have to give little more information regarding that one. That one thing. One more thing, I am giving a time to you to practice the Gauss Jordan method you have to follow. I will send homework to you. Please practice. Don't do homework alone. You do what I have worked out here. That also you work out it. It's very useful. Since you people are getting only free of time, so make use of this one. You will become expert in this subject. No need to afraid of max. I think so. So inshallah we'll see in the next class. Please cooperate us. I want the complete homework. Please submit me through my WhatsApp number. It will be very encouraging me to take further classes in more interesting way. Okay, inshallah it will be very useful to you. We'll see in the next class.